Well, now we're going to do the other question, question B here. Question B says, let's say B1, excuse me, 2p raised to the power of 0. In this case, you know that the law of exponents says that any number a raised to the power of 0 is just equal to 1, okay? So over here, it's just like 2 multiplied by p. P will be equal to 1 now. And then the answer is just equal to 2. And then question 2, it's like 2p to the power of 0. This is like the whole thing, okay? The whole thing within the bracket is raised to the power of 0. So all this is just equal to 1. Okay? And then question 3 is like 2, open bracket 3, a to the power of 0 to the power of 2. Okay? We can solve this like as 2 multiplied by 3 times 1 to the power of 2, which is equal to 18, because 3 squared is 9. 1 squared just 1, so 9 times 1 is 9, 2 times 9 is 18. Or we can also say, we can also do it like, we move in the power of 2, so it's going to be like 3 squared multiplied by 8 to the power of 0, and then this is still equal to 18 because 3 squared will be 9, and then 8 to the power of 0 will be 1. 9 times 1 is 9, 2 times 9 is 18. Question 4 is there. We have like x raised to the power of negative 5, okay? And then this can be reduced to 1 over x to 5. Remember, we just said x to the negative m is the same thing as, or let's say it was a to the negative m is the same thing as 1 over a to the m. Okay. Question 5 will be a to the power of 2 to the negative 2. Here is the whole thing that is at the denominator, so it's like 1 over a squared to the power of 2. Okay, because of the same law of exponents here, it is because of the negative exponent here, it's going to be that, and then this can be written as 1 over a to the power of 4. Remember this law of the exponents. On the right here, a to the m all to the n, this is equal to a to the m times n. Question 6, I'll leave it for you. Even question 7 and 8 and 9, all these questions, I'll leave those questions to practice. I'll leave these questions to practice, and then let's move on to questions. Let's do question 19. Maybe we should still do some of them. Excuse me, 6. See, question 6 is like 2 to the negative 6. This, obviously, according to this law of exponents, as question 4, this will be 1 over 2 to the 6. And then this is like 1 over 2 to the 6 is equivalent to 64. And then question 7, 2 to the 3 times 2 to the negative 5. Okay, let's just move it a little bit up there. Question 7, excuse me. Question 7 is 2 to the 3 multiplied by 2 to the negative 5. Okay, this one, because it has a negative exponent, I will write to the denominator. So this would be just 2 to the 3 over 2 to the 5. Okay, first of all, this product we can combine the bases, because the bases are common. Check the bases. Check this out. This the base is 2. The base is 2. So because the bases are common, we have this law of exponent that says a to the m times a to the n. This is equal to a to the m plus n. Okay. So there we will say 2 to the 3 plus minus 5. And now this is equal to 2 to the negative 2. Now, another law of exponent that says a to the negative m is the same as 1 over a to the m. So we can write it as 1 over 2 squared. Okay, and then 2 squared is 4. So the answer is just a quarter, 1 over 4. And then question 8, we have 11y to the negative 3 times 11y to the 6 times y to the negative 3. Now, we first look at the constant, okay? 11 times 11 is 11 squared, but which is 121. So 121. Now let's look at the variables here. There are y to the negative 3, y to the negative 3, and then y to the 6. So in this case, we can just write 1y, and then we are going to, according to this law of exponents, we're going to add, okay, the exponents. There will be negative 3 plus 6, negative 3. And then all this makes 121 y to the power of 0. And then the law of exponents is like, this is a corollary or definition, is like any number raised to the power of 0 is 1. And then this will be just equal to 121. Okay. If I take another question, question 9. Question 9 says like 4x to the negative 2. Okay. The 4 will remain there, and then I'll move the x to negative 2. The denominator will become x squared, like that. And then question 10 says 4x to the negative 2. Okay, so in this case, we apply that law, the law I wrote earlier, the a to the negative m will be equal to 1 over a to the m. So we're going to take the whole thing in the brackets here as a, okay, 4x, not just 4, not just x, but 4x, okay, and then this will be equal to 1 over 4x to the power of 2. Okay, we can simplify this further. It's going to be 1 over 16x squared, because 4 squared is 16, and x to the power of 2 just x squared. And then I'll leave 11 and 12 for you to practice, because these questions are very similar to 9 and 10. Okay, so I'll leave this one, 11 and 12, even 13, 14, and 15, 17, 18, up to 21, because they are similar. Okay, I'll leave these ones for you to practice using the same law of exponents. Here, when it's a negative power, you can move it back. Okay, so I have a positive exponent, or maybe, okay, let's just do from 18 here. Okay, I'll do from 18. From question 18. Question 18, excuse me. Question 18 says like 1 over 2 times 3 to the negative 2. This is equal to what? So I still have 1 over 2, and then I need to move the 3 to the negative 2 to the numerator. Okay. This will be times 3 to the positive 2. Okay. Whenever a number or a variable with a negative exponent switches, from the numerator or denominator will become positive. So this will become like 3 squared over 2, which is 9 over 2. Now, if you do 19, then 19 is like 1 over 2 times 3 to the power of negative 2. So here it's the whole thing. This is raised to negative 2 because it is within brackets. So we're gonna move like 2 times 3 to the positive 2 there. There's 1, and then nothing at the denominator, so we don't need to write 1 there. And this will be, okay, maybe I can just say over 1, and this is just 2 times 3 to the power of 2, which is 6 squared, and which is 36. Okay, 20. Question 20 says 1 over 20. I'll leave 20 because it's like 18. We can see maybe we can do, I'll leave also 21 because it's like 19, and then we can do 22. I'll leave them for you to practice. So here we have like 5 over 3 raised to the power of -3. That's the question. First of all, we're going to notice that we have a negative exponent here. So we can write it like 3 over 5, okay, raised to the positive 3 there, okay, which is like 3 cubed over 5 cubed, and then 3 cubed is 27, and then 5 cubed is 125, okay, and then 23, 23 here is like 5 to the -3 over 2 to the -3. So over here, we can, you see, we have a negative exponent there, a negative exponent there. We can write it like I'll move the 2 to the -3 to the numerator to make it positive, okay, and I move the 5 to -3 at the denominator to make it positive, okay, and then this is like 8 over 125, okay, and then 24. 24 is like 3 squared over 3 to the -5. So in this case, we can write 3 squared multiplied by 3 to the positive 5 there, and then this we combine like terms because the bases are common, okay, and then this is equal to 3 to the power of 7. 25. We have like, I left 25 for you to practice because it's much similar to a previous question. And then we can do 26. Then 26, what you have, a squared, b squared. Let me move it like this. A squared, b cubed, rather, and then c to the -5, d to the 8, all over a b to the -4, c to the -6, d to the 8, okay. This will be equal to what? A situation like this, just write single variable, okay. I'm gonna write a. If I look at the variable a first, I have a there also. Then when I don't see the exponent, I understand that it is 1, okay? So over here, I will do 2 a squared minus 1. So I do this power here, 2 minus 1. And then I am going to write also multiply by b. Now let's see. B there, the exponents are like, okay, I'll say b there. So I'm gonna say here 3. The exponent will be like 3 minus -4, okay? We minus the exponent of the numerator by the exponent of the denominator. And then the next variable will be c there. Then this will be like c to the power of -5 minus -6. And then let me move this way. We have d, the variable d, and d there. There we can just write 1d like this, multiply d 8 minus 8. And then we can start solving. That makes like a to the power of 1. I don't need to write the power of 1. Multiply by b, 3 minus -4 makes +7. And then multiply by c, -5 minus or -6 makes +1. I don't need to write it. And then d to the power of 0. So here it's like a to the 1, b to the 7, c to the 1. Now d to the power of 0 is just equal to 1. So the answer is a, b to the power of 7c. Okay. Now we can, the same way, we can do questions. Let's say we're going to do question 30 then. Question 30. The same way we can do 27, 28, and 29. Now we can do question 30, that is a 6x squared multiplied by 2x to the negative 3 raised to the power of 2 all over, all under 1. Okay. So 6x to the negative 2, that's what the question says. Now, this can be written as 6 x to the negative 2 multiplied by, at the denominator here, we will have like 2 to the power of 2. We're going to have like 2 to the power of 2, and then x negative to the power of 2, to the power of 2 to the power of 2 there. So 2 squared at 2 to the power of 2, and then x negative 3 to the power of 2 under 1. And then this is like 6x to the negative 2. So the negative 2 here, I can move it at the denominator, or maybe let's just leave it negative 2 there, and then over 1 over 4x to the negative 6. Voila. Now we can simplify these two, okay? Because 2 gets into 6 and 4 in 6 3 times and 4 twice. So it's gonna be like 3 over 2. I'm done with the fraction, the constant, like over 1 there. Now I can do the variables. I'll write 1x, and then the numerator, it was negative 2 here, and then the denominator there is negative 6. So negative 2 minus 6. Then this will be equal to 3 over 2 x to the power of 4. Okay. The same way you can do the rest of the question, 31, 32, and 33. So for practice, thank you.